All right, so we're going to look at some force diagrams. We're going to do 2 examples, one at a time though, okay? We're going to start with what's the point of the force diagrams for action and reaction pairs. The best thing they can do is they can help you identify action and reaction force pairs and kind of see what's going on, which is kind of fun. So I've got some very lovely color-coded ones. So we have a hot air balloon here in this first example, and it's lifting a basket at a constant speed. Constant speed, tells me that there is no net force, which means that there should be balanced forces on everything. So you can see that I've drawn some arrows, and the size of the arrow is approximately the same size up and down on both of these so that they have a net force of 0, okay? And what I did, I've got the arrows here. We're going to go ahead and label them. There's 3 forces on the balloon. The one that's going up is a buoyant force, and then there's 2 going down. One of those is gravity, and then the other one is coming from the basket down here, which is pulling down on the balloon. And so that one is, I called it a tension force because there's some ropes there, okay? And then on the basket down here, I've got gravity again, because gravity pulls everything down. And then the basket is being held up by the balloon, and because there's ropes there, I called that one tension too. Okay, and so now I have those forces. I've got to write sentences, so I'm going to follow that same sentence structure. The force from the agent pushes or pulls on the receiver in a direction, but I am lazy and I have to write a lot of force sentences. Look, there's 5 right there. And so I tried to shorten it up. I left out a lot, and I, instead of writing out the name of the force, I just wrote the symbol. So here's the first one. FB from air pushes balloon up. See how short that is? It's really not that bad. And then for gravity, I've got FG from earth pulls the balloon down. And then for tension, I've got FT from the basket pulls the balloon down. Okay, now I didn't write the ropes there because the ropes are attached to the basket, so I wrote what's on the other end of the rope. Okay, that's actually really helpful in this situation because it's going to help me identify the action and reaction force. That's a spoiler alert, sorry. Now for this other one, I've only got 2 to write. I've got the tension that's up and the gravity that's down. This one I think is the tension. Tension from the balloon pulls the basket up, and gravity from earth pulls the basket down. Now, when I'm trying to find the action and reaction force, the only things that matter, let me pick a different color. The only things that matter here are between the things that are interacting, which is my balloon and my basket. So what I'm going to do is I'm going to underline those things. Balloon, balloon, balloon. Notice that everything in my force diagram for the balloon ends with balloon. Do you see that? Ends with balloon. And then everything for my basket ends with basket. Now, it's an interaction between the balloon and the basket, so I'm going to look for an agent that is a basket or a balloon. There they are. And so now I have found an action and a reaction pair. So here is one of them, and here is the other. Okay, so in your practice, you're going to have to identify an action and a reaction force. And on the test, you're going to have to identify an action and reaction force. And so I've just been able to do that now. They're color-coded, so it's easier to find here. So this what is that, orange? That arrow is right here. So there is maybe we'll call this one the action. Sometimes it doesn't matter which one's the action and which one's the reaction. And here is the reaction. Like that. That's some pretty sloppy handwriting. You can probably write prettier than me. Okay, so that's our first example. So we're able to find the action and reaction because they have that format where we've switched the objects. Basket pulls balloon, balloon pulls basket, and then they've got the opposite direction, down and up. Okay.